In this video, we solve problem 8.8.504.xp from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to determine whether the improper integral converges or diverges. Now, if we weren't told that this integral was improper, we could tell that it's improper because this integrand is undefined when x equals 5. When x equals 5, if I tried to substitute that in here, I'd have 8 divided by 0, and that's not allowed. So this function actually has an asymptote, a vertical asymptote at x equals 5. And we're interested in the area between that function and the x-axis between x equals 4 and x equals 6. So I'm going to try to draw just a general picture of what's going on here. Kind of a cartoon. It's not going to be exact, but it's going to give us a rough idea of what's going on. When x equals 6, that's just a 6 minus 1 in the denominator, or 6 minus 5 in the denominator, and 6 minus 5 is 1. 1 to the 10/3 is, of course, just 1. So we've got 8 divided by 1, which is 8. So this is not to scale. I'm just going to make it 8 right there. And then if x equals 4 on the other side, we're going to have 4 minus 5, which is negative 1. Negative 1 is being raised to the 10th, so that would make that positive 1, because you've got negative 1 multiplying itself 10 times. So we've got a positive 1, and then you're taking that and raising it to the 1/3 power, or taking the cube root. The cube root of 1 is 1. So we end up with 8 on the other side as well. So we've got some symmetry here. As x goes to positive or negative infinity, we're going to take a very large positive number or a very large negative number, raise it to the 10th power, then it's going to be really large, and then we're going to take the cube root. So this is going to be a positive number no matter what x is, as x goes to positive or negative infinity. So we're going to have 8 over a large positive number either way. So the function is going to look like this. It has the same general shape as y equals 1 over x squared. But it's just a little bit different because that's not the second power, it's the 10/3 power. And this is going to have symmetry about the line x equals 5. So the question says, determine whether this integral converges or diverges. And so we're asking ourselves, this area in here, the area between x equals 4 and x equals 6, that area. Is it finite in some sense? In some limiting sense? Is that area under the curve equal to a finite number? And if it's not, it's probably going to be positive infinity because we can see that the function is above the x-axis the whole time. Now, the way we handle integrals like this, where the issue happens on the interior of the interval, is we write this as a sum of two integrals. So we'll write it first as the integral from 4 to 5 of 8 times the quantity x minus 5 to the negative 10/3. Just bringing that up to the numerator. So that's that part. And then we also want to add the integral from 5 to 6 of 8 times x minus 5 to the negative 10/3. Now the way improper integrals work, if this diverges, say it diverges to infinity or the limit does not exist, then we say this does not exist. Or if this one diverges, we say this one diverges. And if this one diverges and this one diverges, all it takes is one of them. All it takes is for one of them to diverge, for this to diverge. Let's say that this one happened to go to positive infinity and this one happened to go to negative infinity. They don't cancel out and give you 0. That's not how improper integrals work. It's not how they're defined. So this we want to define as the sum of two improper integrals, and we'll just evaluate one at a time. If we evaluate one of them and it diverges, then we can say the whole thing diverges. If we evaluate one of them and it converges, then that means there's more work to do and you have to do the same thing on the other side. Okay, so let's call this integral number 1 and this integral number 2. And I'm going to focus on integral number 1 first. Let's just do that over here. Now, all improper integrals should be thought of as limits. So this is really another integral. It's the integral, or it's the limit, excuse me, as b approaches 5 of the integral from 4 to b of our integrand 8 times the quantity x minus 5 to the negative 10/3 dx. And let's see what I mean by that. Well, the fundamental theorem of calculus doesn't apply to this, but the fundamental theorem of calculus does apply on the interval from 4 to b, where b is some number that's less than 5. So what we're going to do is we're going to find that area under the curve between x equals 4 and x equals b. And I made my graph so small, I wish I had made it larger. But there's 4 and there's b. And we're just going from 4 to b. And then we're saying to ourselves, what happens as b approaches 5? Now b is approaching 5 from the left-hand side, so I'll make that from the left over here. And that allows us to define this area where the range is unbounded under that graph, or the range of that graph is unbounded in that, for that interval of x values. We're saying that this is actually defined to be this, and that's a proper integral. So I can use the fundamental theorem of calculus for that. I can find out what that area is as a function of b, and then I can say, well, what happens is b gets really close to 5 from the left. If it approaches a finite number, then we say that that's what that area is. And then we'll do the same thing on the other side and add those together to get the value of that integral if it happens to converge. So let's see if this one converges first. In order to evaluate that definite integral, that definite proper integral, we'll use the fundamental theorem of calculus. Requires a u substitution. Let's let u equal x minus 5. du is the derivative of that times dx, so we just have a 1 dx. And then we also need some bounds, some new bounds. To find the new bounds, you just take the old bounds and you substitute them in over here. So when x equals b, u is going to be b minus 5. When x equals 4, u is 4 minus 5, which is negative 1. So this is, the original integral is the limit as b approaches 5 from the left of this. The new upper bound is b minus 5, the new lower bound is negative 1, and then we have 8, and then that's going to be a u to the negative 10/3 power. And then dx is the same as du. And since I've changed my bounds, I never have to go back to x. All I do is anti-differentiate, plug in the upper limit and lower limit, and subtract using the fundamental theorem of calculus. So first, let's anti-differentiate. Add 1 to the exponent. That'll make that 7/3. And then we divide by the new exponent. Dividing by 7/3 is the same as multiplying by negative 3 over 7. Then plug in the negative 1 and the b minus 5 and subtract. Now I'd like to take out that negative 24 over 7. It's just a constant. So this is going to be a b minus 5 to the negative 7/3. I would rather write that as 1 over b minus 5 to the positive 7/3. And then we're subtracting this evaluated at negative 1. So we've got minus 1 over negative 1 to the 7/3 power. Negative 1 to the 7th is negative 1. You take the cube root of that and you're going to get negative 1. So we have a minus a negative 1 here. So it's going to be positive 1. Okay, now we're here. So we ask ourselves, what happens to this expression as b approaches 5 from the left? So b is a number that's slightly less than 5. Now, if I were to just plug in b equals 5, I'd have 1 divided by 0. And anytime you have a number, a non-zero number divided by 0, that limit is infinity or negative infinity. Let's figure out which one it is in this case. If we're to the left of 5, so that's like something like 4.99, 4.999, 4.99999. This number, b minus 5, is going to be a tiny negative number because 4.999 is less than 5. So it's going to be a tiny negative number. I'm going to raise it to the 7th. It's going to be even tinier. because we're taking tiny, tiny fraction and raising it to the 7th power. And then we're going to take the cube root of that. But that's going to be a negative number when we're done. A very tiny negative number, because a negative number to the 7th and then the cube root of that will be a negative result. So I have 1 divided by a tiny negative number. That's going to be a large negative number. And that means this is going to negative infinity. And then multiplying by this negative 24/7 is going to make the result go to positive infinity. So this limit is infinity, because this part goes, just this one single part goes to negative infinity, and then we have a negative times a negative gives us a positive. And that means this integral from 4 to 5 of 8 times x minus 5 to the negative 10/3 diverges. And it diverges in a special way. It diverges to infinity. So we can almost think of that area there as infinite. Since this one diverges, this one diverges. So I guess we should have stated this at the very beginning. This is equal to this, yeah, provided both integrals converge. But that's not true. This one diverges. And if this one diverges, that means the original integral diverges as well.